In this video, I'm going to revisit these three figures that you worked on previously. Of course, you remember that you had to create arcs that were missing from these three figures based on the information given. And the geometric construction, learning that was useful because it helped you get an idea of what was going on behind the scenes, things that you may not have thought of before. Now, AutoCAD actually has a tool that will help you accurately construct these arcs, but it was important to understand the geometry before you moved on to the shortcut tool. Otherwise, you may have missed something. In fact, on the third exercise here, if you didn't understand the geometry of what was going on, then there's a good chance you may miss something here if you use the shortcut tool. So let's go ahead and work through these different exercises. And the main tool we're going to use here is the 3-point circle. And you'll remember the first exercise, we had to create an arc that was tangent to this line, passed through point P, and had a radius of 3.5. Okay? So what I'm going to do is I'm going to take advantage of being given the radius here, and I'm going to use the offset command to offset this line up by a distance of 7. And 7 is the diameter of the circle that we'll create with the 3-point circle. Of course, the reason we're using a diameter of 7 is because it's twice the given radius, which was 3.5. So let's use the offset command, and I'll offset the horizontal line by a distance of 7. Okay, and now I will use the 3-point circle. Okay, I want to do a one-time override of tangent, T-A-N, enter, and I'll click on this horizontal line. Then I'll click on this point, make sure your node snap is turned on, and then I want to do another one-time override, T-A-N, enter, and I'll click on this line. Okay, so even though we didn't know where the tangent of the circle would be located, just the constraints that we placed on the circle when we created it, it had to fall between these two lines, and basically the edge had to pass through here. The tangent point was wherever it was based on the other constraints. Okay, so now that we've done that, I can erase this line and then trim. Okay, so I want to TR, enter, enter, and let me click on this line so it'll trim it at the tangent point, and then I will trim parts of the circle that I don't need. You have to kind of go inside this node and trim it here. Oops, it's not trimming. TR, enter, enter. Okay, and then trim around. Okay, so let's double check our work. I want to click on the arc. We were given a radius of 3.5, and in fact we have a radius of 3.5. You can see that we have a smooth transition from line to arc, which would indicate that this was at the tangent point. Okay, of course it is, because that's the way we constructed it. And then the other end of the arc passes to the middle of this node. Okay, so that is correct. Alright, so let's work on the next one. Now, on this particular exercise, we were not given a radius, but we were told that the arc passed through these 2 points, and the arc was tangent to this line. Okay, so again, we can use the 3-point circle. So I'll click that, then I'll click on point P, and then point Q, and let's do a one-time tangent override, T-A-N, enter, and then I'll click on the horizontal line, and it makes the circle for us again. TR, enter, enter, and trim away parts of the circle that you do not need. Okay, and we weren't given the radius, so we won't be able to click on it and verify the radius, but we can see what it is. Okay, but it does. The arc makes a smooth transition from line to arc at this point, at the exact center of that node, and it passes to the center of point P. Okay, so now that's correct. Now, if you look at the third one, you'll see that the third one looks similar to the first problem. In other words, the arc has to pass through a single point and be tangent to an entity. On the first one, it was pass through point P and tangent to this horizontal line. And this problem is passes through point P and is tangent to the circle. So you may be thinking, well, I can just offset this line just like we did over here, and then the 3-point circle will work it out. So let's try that. So I'm going to offset by the diameter of the circle that we'll create. So our radius is 6, so let's offset by 12. And then let's use the 3-point circle. Okay, so passes through point P, is tangent, so TAN is tangent to this circle, and then TAN is tangent to that line. Now you would expect, because of the constraints we placed on the on this circle, that when I click on this and look at the diameter that it'll be 12, but it's not. The reason why is you can see that the center of this circle is offset to the right of this point. In other words, the lowest point of the circle doesn't pass through this node. Okay, whereas on this previous exercise, the lowest point of the circle was the tangent point, but that's not so over here. So that's what's throwing this this operation off. Okay, and what you have to do, and you'll have to think about this geometry a little bit, but instead of using that offset line, I'm actually going to create a circle with a radius of 12. Okay, and now I'll use the 3-point circle, and I want to I want the first point to be tangent to the inside of the circle that I just created. Okay, in other words, you know, before I was basically constraining the top edge of the circle to a horizontal line. Okay, but I didn't, and I shouldn't have done that for this particular exercise. Okay, and I was able to determine that by double checking my work. So I want to be tangent to this circle and then pass through this point. Okay, so now it dropped the circle in there for me. Now if I click on this circle, it's exactly a diameter of 12. Okay, so by using a circle here to be tangent to instead of that horizontal line, it allowed this circle to have the correct diameter. All right, so let me erase that outer circle and then trim TR enter that circle there. Okay, so let's double check our work. This arc has a radius of 6, and it is tangent to this circle, and it passes to the center of point P. Okay, so these should look exactly like your previous construction. To compare, you can actually click on these lines, these arcs, and see if your arc lengths are the same between the one that you constructed manually and the one that you did in AutoCAD. Okay, to see if they're the same. And I hope this helps you out, and this concludes this video.